One of my colleagues at Input Output bought some ADA for his nephews and nieces. And of course, I don't know any details about that. But just imagine you want to make a gift of ADA to a child. So you want the child to own the ADA, but you only want the child to have access to the ADA when he or she turns 18 or 21 or whatever. And using Plutus, this is very easy to implement a scheme like that, a vesting scheme like that. In this week's code folder under lecture vesting, you'll find the vesting module, which is an implementation of a very simple vesting smart contract. So I use the technique that I showed you at the end of last week's lecture, using typed high-level Plutus with custom data types. So in this case, the custom data type is the datum, which I call vesting datum, and it contains two pieces of information, a beneficiary and a deadline. So the beneficiary is the pub key hash and the deadline is POSIX time. So the idea of the smart contract is that it should unlock only after the deadline has been reached and only if the transaction that does the spending, does the unlocking, is signed by the key of the beneficiary. So this is the code. So we use this type as datum. We don't need a redeemer, so we can use unit, script context to bool. And we have to check these two conditions. So signed by a beneficiary and deadline reached. So we have helper functions for that. And we use this trace if false to give a debug or trace error message in case these conditions are violated. So signed by beneficiary is easy. We make use of this tx signed by function, which comes from the Plutus libraries. And we see it takes tx info and the pub key hash. And then it returns true if the transaction under validation has been signed by this pub key hash and false otherwise. And txinfo is the type we looked up earlier, the part of the script context. So we can easily get the txinfo from the script context. So this is the first time, the first example where we actually make use of the provided context and don't just exclusively look at datum and or redeemer. And we know the beneficiary from the datum. So this here is the beneficiary field of the datum. And we just use this tx signed by function to check whether the beneficiary has indeed signed the transaction. So the more interesting condition and the one relating to time is this one, where we want to check whether this validation happens after the deadline has been reached. So even the beneficiary will not be able or should not be able to unlock this UTXO that's locked by this script before the deadline has been reached. If we look at this crude diagram, so this is time, and let's say the deadline is here. And let's consider a transaction with, let's first say this validity interval. So recall what that means. Before the validator script is run, other checks are made, including the time check. So the node checks whether the current time falls into the valid range of the transaction. And only then is the validator run. So we know now that we are in the validator, the current time lies somewhere in the validity interval. But if this here, the first one, would be the validity interval, then the current time could be, for example, here, which would be fine. It would be after the deadline. But it could also be here, which would not be fine. It would be before the deadline. So this validity interval is no good for us. We mustn't declare the transaction to be valid if this is the validity interval. This, on the other hand, is fine. We still don't know where the current time exactly is. It can be anywhere in this interval, but no matter where it is, it's after the deadline. So we must check that we have this situation, that the whole interval is to the right of the deadline. And one way to do this is to use this contains function that we played with earlier. and look at this interval, the half open interval that starts at the deadline and stretches into infinity. And if this interval contains the validity interval of the transaction, then we are good. Then we know no matter where the current time is, it will be after the deadline. So we know the deadline is the second field from our datum, which we can get with the deadline accessor. So this is now the deadline. And we have the info valid range that we discussed earlier from the transaction that we get from the TX info field. And as long as the current time interval is contained in this one, we can be sure that no matter what the actual current time is, it will definitely be after the deadline, and that's what we want. So this is a way to define this deadline reached condition, and we have the signed by beneficiary, and the combination of the two, the logical AND, gives us the logic we want. So a UTXO sitting at this vesting address can only be unlocked by a transaction that has been signed by the beneficiary and where the deadline has been reached. And this concludes the implementation of the smart contract of the Plutus script. So it's a nice simple example of how to use time in a smart contract, and I think also a quite generic and useful example. These vesting situations are all over the place and occur in a lot of contexts. Of course, this is not the only way how you can implement such a vesting contract. For example, now we insist that the UTXO is unlocked by the beneficiary, which of course makes sense, but there are alternatives that you could think of. For example, you could also allow other parties to unlock the vesting, provided they pay the actual value contained in the UTXO to a specific address, beneficiary address. That might make sense, for example, if you want to offer that as a service. Maybe the person, the recipient of the vesting, in my example, the nieces and nephews of my colleague, are not very blockchain savvy and don't know how to issue a transaction that actually unlocks this vesting. So maybe you want to do that yourself. So in that case, it would make sense to change the logic so that anybody can issue the transaction that actually unlocks it, provided the money ends up with the beneficiary.